And that's it. Hi, Abby. Hi, Maggie. We were just talking about how we're going to go over a couple big ideas before we go over the remaining of the questions in number 8's packet. The packet number 8? Anyway. So when you guys see a slope field and you're matching with differential equations, what do you think? Where it's 0, maybe? Where the slopes are 0? It meaning the slopes? Okay, so where do you guys see the slopes being 0? Good, y-axis. And what is going on the y-axis? Who equals 0? That's important to know. Tick mark. Tick mark on the x. So it's x equals 0. This one's a tick mark on the y, the horizontal line. That's y equals 0. Silly way of remembering, but it works. So tick mark, that would be y equals 3. This one, that'd be x equals 3. Okay. So we have x equals 0, y equals 0. Riley already pointed out that on the y-axis, all the slopes are 0. Can you guys figure out what's going on when y is 0? All the slopes are follow the flow? Undefined, yeah. So that'd be DNE. What's the only way to have, well, not the only way, but one of the only ways to have when x is 0, the whole thing's 0. When y is 0, the whole thing is undefined. Wouldn't that work? If x is 0, the whole thing's 0. If y is 0, the whole thing's undefined. So let's see if anything matches up with that. If x is 0, the whole thing's 0. If y is 0, the whole thing's 0. That doesn't work. If x is 0, the whole thing's 0. If y is 0, the whole thing's 0. That doesn't work. If x is 0, the whole thing's undefined. That doesn't work. Ooh, that one looks kind of good. If x is 0 and y is 0, the whole thing's 0. Nope, nope, nope. I need y to be undefined. Or the derivatives, sorry, the slopes to be undefined when y is 0. So this one was way too easy because there's only one that even fits those two first things that most people would look for. However, what else could you have done? What else could you have thought? Plugged in actual points, yeah. Well, because I think you were thinking plugging in points, right? Like you could have plugged in 1, 1. 1 times 1 is a positive. That's downhill. Nope. 1 times 1 is a positive times a negative. Okay, maybe. 1 times 1, or 1 over 1 is a positive times a negative. Okay, maybe. That's a negative. Okay, maybe. 1 minus 1 is 0. No, that doesn't work. Okay, let's go plug in more points. Maybe something in the second quadrant. Maybe something in the third quadrant. Maybe think about how all the x's and all the y's in the first quadrant are positive. Unit circle. Positive, positive, negative, positive, negative, negative, positive, negative. If I plug in a positive x with a positive y, this needs to always be negative. This one, not always negative. If y is big, I already crossed that one out. So there are other ways of narrowing down, plugging in points, etc. But this is when you have a slope field matching with a differential equation. Just in general, what do you think when you have a slope field matching with an original equation? Follow the flow. Now, how many of you guys knew what ln of absolute value of x was going into this? Maybe a few. Most of you guys forget, but that's okay. Let's just talk real quick about absolute values because they'll show up in one place or another. If you have absolute value on the outside, you would take ln and what would change? It was on the outside, the absolute values. Yeah, in a sense, because I need all the y's to always be. So what about these negative y's? It's going to be like that instead. But that's if the absolute value is on the outside. The one that you guys are probably used to for this example is something like that. And you probably got used to in pre-cal algebra 2 the w. The negative one would flip up. That was absolute value on the outside. Most people, though, forget absolute value on the inside. Absolute value on the inside, the transformation is very different. Let me give you an example with the parabola. What if this was the parabola? And let's say we were to take this parabola and do absolute value of the function when this is the function. Absolute value would say keep everything to the right. Oh, I did not do that right. Thank you. Inside, inside. Come on, self. Okay. Keep everything to the right because the positive x's stay the same. Positive x's to the right. Negative x's lose their identity in whatever different they would have done. Doesn't matter what was there. So instead of taking away what was below, taking away what's on the left and saying, you have to copy the other guy. Sorry. So how does that work with ln of absolute value of x? Why am I reviewing algebra 1? Because a lot of you didn't remember it. That's okay. Algebra 2. A little bit of algebra 1. Who's ln? That guy. Why isn't he over here? Because ln doesn't exist for negative x's. But all the negative x's just became positive. So therefore, oh, he's going to copy. Follow the flow. Okay, absolute value. Sorry, something quick I just wanted to go over. Otherwise, we went over multiple choice questions yesterday. But do we have any other multiple choice we need to go over? 7, 9. We didn't go over those? Okay, we'll go fast. Ooh! I love 7. He should take you 15 seconds. If you get the concept. No. That's the hard part. The concept ones, there is not much math to do. So if you don't have the concept, you miss the question. But if you do have the concept, boom, I just gained myself extra seconds on a hard one. Okay. Perpendicular. Just tell me from math. When you see perpendicular, what should you think? Opposite reciprocals. Yeah, a t, 90 degrees, but opposite reciprocal slopes. Slopes. Differential equations are slopes. So this needs to, well, here's a better way of looking at it. Aren't we solving for g? So g needs to be the opposite. That one's great, if you know the concept. But slopes, differential equations show us slopes. What else can remind us of that? When you're looking at slope fields, you're looking at the slopes for differential equations, right? So when you see slopes, particularly slopes of g, sorry, could have been slopes of g prime, and then that's g double prime. But anyway, slopes of g, look at the derivative. Don't worry, that one's a good one, but it's also a lots of people would have gotten, don't worry. If you guys get that, just download and open or refresh. I'm just too lazy to refresh and then have it not work. So, here we go. Number 9. P.S. If you're bored. Oh, my poor bored ones. Did I never get you guys number 10? Oh, my bored ones. Here you go. I'm looking out. Yes, 0 period tomorrow. Yeah, Cameron. To be honest, no, and it's really weird, but I also forgot to ask all of my classes. Because I think it got stuck in someone else's pile.
This is my favorite.
No. Because, hey guys, real quick on the 0 period stamp sheet. Cameron, it's not going to be a 0 for sure in any way, shape, or form. If anything, your forever final might just count double. Or I just make it excused. Either way, whichever one's more helpful for your grade, if I truly can't find it. The weird thing is that that pile never got separated from the others. It was always in a paper clip. So that's why I was thinking that someone just has it and they haven't yet. But guys, for the stamp sheets, we are technically on April week 3. Let me write your name down, Cameron. I don't remember. We are in April week 3, and you're like, wait, no, April week 3 is shaded. Yes, because last year this was spring break. Exactly. I shaded the wrong one, which is why I had you shade March week 5, which was our spring break. And so April week 3 is a stamp. That's this week. And then April week 4 is also a stamp. That's next week. And then April week 5 is the same as May week 1, which will be our last stamp. So you technically have 3 more stamps to go because the shading was off. Well, I could do a whole new stamp sheet for 1 week, but I don't do that. So even though there are shadings, we are finishing off April, the 3 weeks. This week, next week, and then the next week. And then AP start. Okay, here we go. Sorry, I apologize, number 9. Cameron, thank you for reminding me of that. It's in the back of my head sometimes, but not usually when I see you, and it's a struggle. Number 9. You guys have all double, triple checked your forever quizzes that there's not someone else's in your double check tonight, please. I know it's weird, but the likelihood of it disappearing from my files is much smaller than the likelihood that it's just attached to someone else's paper. Not attached, like stapled, but stuck. Hey guys, look at the answers. Aren't they wise? Oh, didn't we do this one yesterday?
Yeah.
With Maggie. Okay. It's on the video. Don't worry. It's on the video. Sorry. Number next one. Which one? Yeah. We can peek at it real fast. Guys, how would you separate? Just because it's a little bit trickier than some of the other ones, how would you separate? Why are we separating? Because what do we need to do? We need to integrate. So to separate, the very first thing, don't divide by anything. The very first thing, multiply dx. Get your differentials where you need them to be and then figure out the rest of life. But as you figure out the rest of life, who does not belong? And y is in the cosine squared. Why wouldn't you just integrate right now? Because it's a lot easier to integrate if you see that he's secant squared. Where's my Plug in your y, pi over 4, plug in your x, 0. Tangent of pi over 4 is? Square root of 3 over 3, 1. Square root of 3. Or square root of 2 over 2, square root of 2 over 2 cancels. You end up with 1 equals c equals 1. So then we could plug in. I probably should have gotten y by itself. I was just being lazy and plugging in right away. Lo siento. But take arctan of both sides, and you should be C. Good. Right? Stay. Okay. Anything else? Multiple choice? Going once? Going twice? Is there one I missed? Okay. FRQs. I'm just going to go straight to the answer key if that's okay, because then we can look at answers and time. What do we got? Any questions on one? Okay, good. Good. Real quick on number 1. Do you guys see how on letter B? Yeah. Oh, nice. Go, answer key. Didn't even realize I did that. On letter B, did they simplify the second derivative? Why not? Because an AP teacher made this and they were like, don't you dare simplify. Because the problem says what for letter B? Are there x's and y's? Good, I'm done. Pause. If you had plugged in a dy dx, which you needed to because it was implicit differentiation, you could not have stopped with just dy dx, like literally notation. That wouldn't work. You have to actually get the x's and y's in. But as soon as the x's and y's are in, please stop. And here's why. I was grading with 2 other people. BC FRQs, but also the ones that were makeup FRQs. And believe me, it's not that atypical based on the other FRQs that were graded earlier. This week? Last week. Anyway. Guess what was said at least between me and them, at least 15 times? Why did they simplify? Guess how many BC kids I had to take points off of because they wrote this. And if they had just stopped there, they would have kept the point that I showed and then had to take away. And guess what happens on AB FRQs? 2. Because I had a BC kiddo helping me with AB makeup FRQs, and guess what they kept on saying? Why did they simplify? And one of your classmates, I don't remember when I found this out, but they tried to simplify this, and they multiplied by, and I don't even know what, something magically horribly wrong happened. So if you had this, guess what the AP grader has to do if you do this and then make it wrong? Isn't that sad? You do not have to simplify. And here's something else. Here's something else. If you have this perfect and you randomly say something, I don't know, super dumb somewhere in this answer for B, in B's box. Let's say you put something like, I don't know, you were just trying to remember stuff real quick and you accidentally wrote this over here when it was really 3x over y. If it's not crossed out, if it's crossed out, they have to totally ignore it. They cannot give you points or take away points for anything crossed out. So if you're ever questionable on something that you've written and you have like an answer that you're pretty solid on, cross out the questionable stuff. If you do any mental math off to the side and you use it somewhere, just making things up, and you use it somewhere and then you're like, I'm not sure that was right. Okay, cool. They have to ignore it. But maybe it helped you as far as a positive or a negative, etc. But if you wrote something bad somewhere else, even though the answer is right, guess what else they have to do? Well, if you use the mental math to write a wrong answer. Does that make sense? Yeah. So they can't take points off for whatever they can't see, but if it led to, they can probably tell what happened. Does that make sense? Arian. Yep. Not every single point on the answer, but they would have to take away because they have to mark something wrong. If there is incorrect information, they have to take off a point. Try not to. Or if you're doing like mental math scratch work, like cross it out and then use it. Which is why, wait, guys, you've seen me do this though. Haven't I told you not to simplify and to do things like, hey, it's positive, I don't care what it is as long as it's positive? Haven't you seen me talk about if it's negative, I don't care what it is, but it's negative? Haven't I told you when you write an integral, you better have a dx, because if you write an integral without a dx, it happened to a lot of people, not just you. It's okay, we're learning from our mistakes. Okay, I just wanted to make a point. Take it away. So wait, no one had a question on letter D? Like you guys all aced D? Oh, we did. Okay, thank you. Sorry, I went over it in period 1 today. They didn't get to FRQs at all. How about FRQ number 3? Let's work on that. B? Yes! B, another common mistake. Thank you. It's one that I've been trying to drill into your head. So let's see how it worked. For B, let me just start here. First of all, remember, if you don't do what, will you receive no points? Okay, so the very first thing you should do, dx, right? Then at least they know that you're trying to separate, even if you do it incorrectly. They at least know you're trying to separate, right? Oh, eventually, hopefully, you end up with the following. True? Now I'm good to go. What if you didn't write the dx? I've been telling you. Just now maybe it'll make an impression and you'll remember. Okay, come back. Why would this not even be a check? Well, technically. You would probably have a check for that. You'd probably have a check for that. And then you'd have a big ol' negative sign. It is negative. It is sign. I did not, whether mentally or actually, walk through the steps of mentally or, I talked about this. I know some of you can do in your head the u and then the du and then the divide, then the put the 1 over pi. But you have to walk through the steps. If you don't walk through the steps, whether mentally or physically, you can get in some trouble because that is not right. That is. Does that make sense? If that was your mistake, get out a different color pen, highlight, star, something, because it's one of your common ones. Okay. I'm guessing that was the problem, because then at that point, what do you do to both sides? Remember, the plus c is stuck now, yeah? I can end up with the absolute value of the c ends up multiplying in front. Plug in your, well, technically you can take away the absolute value because of the whole plus or minus idea with the c. Then you can take your, he's there for a reason, plug him in. 1 plugged in is quite disgusting, so that's fun. Oh no, it's sine of 1 pi, and sine of pi is 0. And anything to the 0 is 1. And so I could say that 2 needs to be which is why the answer is what it, wait for it, is. Plug in the 2. Pause. You're actually supposed to write the equation at the end, right? With the C plugged in. Okay, write the equation at the end. But then plug in the 2 and then dun 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 dun. Oh, that's a good question. What did they do? Oh, I did it. You guys even tried to correct me. Silly me. I made your common mistake. We should sue. I've been grading too much. Yeah. It's positive.
Oh, I knew it was
positive. No. Yeah, you guys tried to correct me. That was totally my fault. Thank you.
Okay.
They did use the word truncate. Okay, any other questions on FRQ number 3, which was really our second one, but either way, you know what you're talking about. Okay, 8P, not 8P, sorry. LTF number 8, pass it up. Number 9, grab it out. Number 9 was on what? Position? Velocity? Acceleration, aka motion. Did anybody get stuck on or confused by any problem? Okay, I'm sure there's more. You guys are saying, yeah, not actually showing me hands. Go team. Ready? Powwow. It's not going to take me long to grade these LTF number 8s. I did it pretty fast this morning. And hopefully you guys know how you get full credit on these, right? You try them, you grade them with a colored pen. The end, right? Okay, just in case. A few of you guys are making like the same mistakes over and over, but hopefully these are perfect and I can zoom, 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 zoom. So number 9, I want you to grab it out. Motion. If you have any questions, ask people right around you or move to someone that you've been able to collaborate well with in the past. I'm pausing the video because Maggie and Abby don't need to hear me grading. Maybe it's okay. All right, cool kids. We need to go ahead and look at number 9 questions. We have about 10 minutes. 5 minutes? Something like that. More than 5, yeah? Okay, number 5, multiple choice. Ooh.
Can you do one first?
If I can pull it up. Sorry. It's coming.
It's okay.
That didn't help.
Everyone died and everything that isn't one. What's the guy from the Scarlet Letter? You should name this hedgehog.
Dimsdale is the Scarlet Pimpernel? Oh yeah, but that's not Scarlet Pimpernel. Oh, I was like, that's not Scarlet Pimpernel. What are you guys talking about? Scarlet Letter, yes, Arthur Dimmesdale, right? That makes so much more sense. All right, number 5. No. Totally different. Totally different. They watch it in French, I think, or they used to. All right. Hey guys, focus. Let's go and get something done. So, we're given velocity, which is the derivative of position, true? And we're given a 10-foot stand is where the rocket is coming up from. If it helps you, can't you say that the rocket is being shot up and it's coming back down?
Yep.
Okay. The initial height would be 10. The ground would be
0.
A height of 0. Right? Number 5 says, what is the position of the rocket after 2 seconds? After 2 seconds, now there are a couple different options that you could do, but since it is a calculator problem, let me show you the easiest one. Number 1, they would never round to the nearest tenth. But number 2, at or after 2 seconds, don't you need to start with the 10-foot stand and then talk about how much the position changes? Ooh, what formula is this? Integration as net change is one way. It's not the only way, but integration as net change is one way. To find the position at 2, start at 0. Where did it start from? How much did it change? And then go ahead and add the 2 together. Now here's the dilemma. Not the dilemma, but the alternate way of solving. What else could you have done? Yeah. You could have found by integrating indefinite integral, right? Yeah. Then you would have had once you solved, a plus c. Once you have the plus c, what do you have to do? Plug in s of 0 equals 10, right? Plugging in 0, 0, 0. So C is equal to 10. Then you could plug in 2. Yeah, that's definitely one way. But since it's a calculator problem, this could have been a little bit faster. Now, in this problem, would this have been nice to have for that problem? Because what do I do for number 6? Set the position equal to 0. Now, hold on. Some of you are like, easy, use my calculator. The problem is, I'm not so sure we can use our calculator super well. So, what are we going to do? Literally. Tell me. Math? No, don't do that. Input 50? No, we're setting equal to 0. Yeah. Why don't we just graph it and find the 0? It's okay. We need to learn how to use our calculators before the AP. We can graph, sorry, people, we're doing, BC kids are doing FRQ stuff up here. I'm not going to actually do it, but guys, literally you would put this function, the position function in. If we need to find the zeros, we can't find the zeros unless we actually plug and chug, right? Play with our window a little bit if we need to. For instance, don't we know that the position starts at 10? So wouldn't a 10 by 10 window not be a good idea? We have to go ahead and zoom out to see what else is going on. And then, well, how are we going to find the 0? Well, we're going to go ahead and after we have a graph, which of course we don't because I didn't put in a function, we're going to use the 0 feature because the x-intercept, or the 0 of this, will be when the rocket hits the ground. No, 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 it's a parabola. I'm going to have 2 zeros. I know. But this one doesn't count, does it? Because it was before time even started and before the rocket was even launched. Then, Riley, you also said number 7, right? Yeah. So then for number 7, same situation. This is the one I like. Okay, do you guys see that there are 2 different categories of answers or characteristics right here? Falling or rising, rates increasing, rates decreasing. Rates increasing, rates decreasing, falling or rising. Now pause. The words that you should be most familiar with is rate and increase, decrease. Pause. Increase, decrease. Attach it to a forever card. Quantity is increasing or decreasing when quantity's derivative is positive or negative. True? First derivative test. Oh, well, the first derivative characteristics. Increasing, decreasing test. A quantity is increasing or decreasing when its derivative is positive or negative. Now, who needs to be increasing or decreasing? The rate. And the rate is the velocity. And I need velocity prime to be positive or negative for this second characteristic. So I'm looking at v prime of 3 for this one. Acceleration, I think, Isa, you said that, and you're totally right. I'm looking at acceleration. I'm looking at, or Justin, that was you, v prime, either way. I'm looking at v prime, I'm looking at acceleration. Why? Because I need to know where v is increasing, so I need v prime. You guys had v up above, plug and chug, and what do you end up getting when you plug in 3 to v prime? Isn't it negative 1.6? It's negative 1.6. So that's going to be less than 0. So therefore, decreasing rate. So I know that's not, and that's not. Why? Because the velocity is not increasing as seen by velocity prime sign. And velocity is not constant as seen by velocity prime not being 0. Now hold on. Rising and falling, then what's that talking about? Going up, going down, moving right, moving left, the sign of velocity. So all I have to do is plug into v. And v of 3, when you plug in, I think is positive, right? So therefore, rising at a decreasing rate is the only possible answer. Is that it? Do we have one more minute? Nope, we don't. Kiddos, first thing tomorrow,